Hello everyone, welcome back to my next tutorial in Creo Parametric. In this tutorial, we are going to learn how to model this flange coupling assembly using Creo. This is the assembly view and this is the cut section view of the flange coupling. In that flange coupling, we have 5 components. One is a flange, and the second one is the shaft, third one is the taper key, and fourth and fifth are the external bolt and nut. Now this one is the cut section view and this is the part view. From that we are going to model the part, then we are going to assemble it. First we'll model the every component using a part modeling, then we'll assemble it by using assembly model. For that, first go to the Creo Parametric. Before starting this assembly model, first select the working directory. Go for select the working directory. Set the working directory where you want to save all the part model file. I want to save it here. So this is my working directory. Then start modeling the first component. My first component is flange. So we have a front view and side view. By using these two views, we need to model the flange. For that, first go to the software and keep the file parallelly. Now we can model it parallelly. For first go to new. Here choose solid part and tick this use default template. Say OK. Our units are in mm. Here you can see all the dimensions are in mm. So choose mm template. mm Newton solid part solid absolute. This is our unit template. Save OK. Now we have chosen a unit template. Then we'll model it. First I'm going to choose right plane, sketch view. This model I'm going to create it by using a revolve tool. For that, start with the center line, which is datum center line. Just create a datum center line, press the roller to confirm. Then just create only this sketch, then revolve it 360 degree. Take a line, start with any one of the line. I'm going to start with this line. Just start it from here to here. Press the roller to confirm. Again press the roller to confirm. Now here this dimension is they have given 190. Then go for dimension. Select this point, this axis, and again this point. Press the roller here. This dimension is 190. So 190, enter. And this dimension they have given, which is 47. That is dia 45. So just go for dimension again. This point, this axis, and this point again. Press the roller here. This one is 45. Then take a line, one horizontal line and vertical line, horizontal, then close and close the sketch. Press the roller to confirm. Again press the roller to confirm. And now we have created the sketch. Then specify the remaining dimension. First set the dimension from here to here. Press the roller here. It came inclined, so just select it and delete it. Again go for dimension from this point to this line. This dimension is 75. Just keep it. Sketch view. Just keep it here. Just keep it here. And this dimension is 20. So go for dimension again. This one is 20. And this dimension is 90. Here you can see. So from this point to this point to this point, just click it here. This one is 90. Now we have set all the dimension. Press the roller here. Just say OK and revolve it just close it, select this revolve one. Now it is came as 360 degree, just say OK. Now we have created 360 degree revolve. Then we just want to create this keyway cut. For that, take this front plane, sketch view. Here we have one more option, which is clip view. It will give the cut section view. By giving this view, we can easily modify the inner feature. Now I am just going for a clip view and take the reference, this one, and this one, then close it. And here you can see it is a taper of 1:100, and from here to here the dimension is 47.9. Just take a reference of this line also, then close it, take a line from here to here and inclined line, and close it, press the roller to confirm, again press the roller to confirm. And this dimension is 47.9. This one is 47.9. And to calculate this length, the taper will be calculated. Just go for the calculator. 1/100 into total length. That length is that small distance from this point to this point. So 1/100 into length is 75, that is 0.75. Then 47.9 minus 0.75. So this dimension is 47.9 minus 0.75. So this is the taper. Then say OK. Then extrude. Make it symmetric. Material removal. The thickness of the removal is taper thickness is 14 mm. Just 14. So bottom also it's cutting. Just go for the sketch again. Edit view. Just take a line. Go for the cut section. Go for delete segments. Remove this. Say OK. Now we have created the cut. Then we just want to create this hole for bolt. This hole here they have given 4 holes. They are 12 and PCD of 140 equally spaced. So just select the surface. Go for sketch view. Take a circle. Before that, just take a reference of this line. Then close it. Take a circle. Just create a circle. And the diameter they have given is 140. Just go for dimension. From this point, this line, and this point. Press here. Before, just make a center line. Just go for dimension. From here to this axis to this point. This VCD is 140. And the diameter is 12. Say OK. Go for extrude. Change the direction. To next material removal. Say OK. The same hole has to be patterned by using axial pattern. For that, use a pattern. Here we choose axis pattern. Choose the axis of the model. This is the axis. Here we make it angular of 360 degree. We need a four locations to make a hole. Just say OK. Now we have created. Then here you can see there are rounds 1, 2, 3. These rounds has to be defined. Here given all the fillets and rounds with a radius of 3 mm. So just use the round. This edge. Press the control and hold. Select this edge and this edge. This edge doesn't have any round, so you should not make any rounds here. Just say make a radius of 3. Say OK. Now we have created this flange. Then just go for standard orientation. Save it with edges. Just hide the sketch. Now we have created this model. Then we can save this file. Just go for file, save as, save a copy. This one is the first component, which is flange 1_FLANGE flange. Just save it. Now the component is saved. Then go for file, close. Hello everyone, welcome back to my tutorial. In last tutorial we have seen how to model this flange. In this tutorial we are going to see how to model this shaft and taper. For that, first go to the Creo software and keep this file left side. Now we are going to model the shaft by seeing this front view and side view. Shaft, it has a length of more length, but they are not given the dimension of this one. We'll take a total length of 150 or 170. Here they have given 90, so remaining we will give 100. So just go for new solid part, untick this default, use default template, save OK. Our units are in mm, choose mm part solid absolute, save OK. Switch on all the planes and axes. I'm just taking the front plane, sketch view. Now the diameter of the shaft is, here they have given 45. So take a circle, just create a circle, press the roller to confirm. The diameter is 45. Go for fit screen, save OK, go for extrude. Here we make it symmetric. The total length is, we make it 190. This dimension I just given as 100. So this 90 they have given, just 190. Save OK. Now I have created the shaft. Then we just want to create this keyway cut. For that, the cut starts from 39.5 from the bottom edge. We can use this mid plane. The diameter is 45, so the radius will be, just go for calculator, 45 divided by 2, that is the radius of 22.5. We need to minus this 22.5 from the 39.5 because our plane is in the mid side. So we make it 39.5 minus 22.5 will get 17. So we need to move this plane 17 mm from here. So select this plane, go for plane, this direction, we need to move it as 17 mm, save OK. Now take this plane, sketch view. Any one outside we can draw it. First to take the reference, this one and this one. Then close it. First take a circle, press the roller to confirm. Now the diameter of the circle is 14, so make it 14. Take a line from here to here, press the roller, and from here to here, then close the sketch, press the roller to confirm, again press the roller to confirm. Go for delete segments, delete these unwanted segments. Now we need to define the height, which is 90 mm. So from dimension, from here to this edge, the dimension is 90. Now we have set all the dimension. Just say OK. Then go for extrude. This side. Here we make it 2 next. Material removal. Save OK. Now we have created the keyway cut. Here you can see it has some rounds. So just do the round of 3 mm. Here also. Just go for round. Here, which is 3 mm. Now just cancel it. Yes, this is in this way only. Here we need to make a chamber which is 2 into 45. Go for chamber, select this edge, the chamber is 2 into 45, so here we change into 45 into D, the D is 2, just save OK. Now we have created the shaft. Now we can save this file. Go for file, save as, save a copy, the same location, the second component is shaft. Just save it, then go for file, close. Now we will create the third component which is tapper key. Just go for new, part solid, untick this use default template, save OK. Our units are in mm, so just choose ns part solid absolute, save OK. Tapper key I'm just taking for front plane, sketch view, take a center line, press the roller to confirm, take a line, press the roller. Now the total length is 80, fit screen. Now take a line again, incline line, close it, press the roller to confirm, again press the roller to confirm. The height is they have given here is 14, so this dimension is 14. This dimension they are not given, instead they have given a tapper is 1:100. The same way we need to calculate. The simple way of calculating distance from this point to this point, height is 1/100 into length, that is 0.8. Just go for calculator, 1/100, that is the tapper ratio, into 80. You will get the height of from this point to this point. If you want to get this height only, you just minus this height from this 0.8. So what we can, this is 14 means this dimension will be 14 minus 0.8. 14 minus 0.8, that is 13.2. No, this height is 9 mm, so this height is 9 mm, and this height is same way only 1.9 mm, so 9 minus 0.9, that is 8.1 mm. This height is 9 mm, width only 14 mm, so just save OK, then go for extrude, make it symmetric, the width is 14 mm, just rotate it, just save OK. Now we have created the tapper. For assembly, for easy identification, I am just going to give a color. For that, just go for view, any color you take. This surface is the flat surface and this surface is the long surface. Press the Ctrl and select both the surfaces and click this blue color again. Now we have given the color. Now just save this file. Go for file, save as, save a copy. The third component, tapper key, just save it. Hello everyone, welcome back to my next component. In this video, we'll see how to model hexagonal nut and bolt. First we'll start with the bolt. For that, first go to the Creo Parametric software. Just close the previous component. Now we'll start with this bolt. For that, first go to new, solid, part, untick this use default template, save OK. Here you choose part solid absolute, save OK. First we need to create this hexagonal head. For that, just select this front plane, sketch view. Here there is an option called palette, just click it here. In that palette we have profiles and polygons. In the polygons, simply choose 6-sided hexagon. Just double click this one and place it here. Then close it this one. Then move this to center point and press the roller. Now we can simply delete this one and create a dimension of from here to here. The dimension is, this is M12, so we need to give a diameter of 24. Go for fit screen. Now we have created the hexagon. Just say OK. And thickness of this head is 8 mm. Just go for extrude. Just go for symmetric. This one is 8. Say OK. Now we have created this hexagonal head. Then we just want to create a rod. This with the length of 18 plus 34 with a diameter of 12 mm. Just select the surface, sketch, sketch view, take a circle, press the roller to confirm. This diameter is 12. Just say OK. Then go for extrude. The total length of the extrusion is 18 plus 34. Just enter it. The total length is 52. Just say OK. Then we just want to create one chamber. For that, just go for the chamber, select this edge. Here we make it 45 into D. This one you make it this one 1. Just press the roller to confirm. Now we have created this chamber also. Then here you can see clearly there is a chamber in this hexagonal head also. For that, you choose the plane. The plane has two sides. One is this side and this side. So we need to choose this plane. Then go for sketch and sketch view. Here we can go for cut plane. Now just take a reference, this edge and this edge, then close it. We are going to cut this chamber by using a revolve cut. For that, use this center line, press the roller to confirm, then take a line, just create one triangle. This both lines are same length. I'm just giving 5. We can go for 3 also. I'm just giving a 3. Just say OK. Then go for revolve. Here you choose option called material removal. This chamber is enough. If you want more chamber, just increase the length of the triangle. Just say OK. Then we need to create a thread. They are not specified the thread dimensions. Now we'll create a manual thread or by using a revolve sweep, by using helical sweep. For that, just select this mid plane, go for helical sweep. Here there is an option called helix profile. Go for define, select this plane, sketch, sketch view. Go for a cut section. Now just draw the center line because this helix requires a datum center line. Press the roller to confirm. Then go for a line. Here we are going to create a line. Before that, just create one reference this. Then close it. Take a line. Create a line just starting away from the point. Then press the roller to confirm. Again press the roller to confirm. Now our helix profile will start from this point. If you want to change this point, just click this one. This arrow will get changed. Now the thread length is 18 mm. So just go for dimension. From this point to this edge, the dimension is 18 mm. This is, you just keep it some 30. Press the roller to confirm. Just say OK. Now we have defined the helix profile. If you want to change the arrow, by clicking this one, we can change the arrow. Now we just want to start the helix profile from this point. Now we need to define the way profile of cutting. We are going to use a triangular thread. For that, the pitch will be also in 1 mm and make the triangular cut. Here. Just go for sketch and sketch view. Now we need to create a triangle here. Just take a line, symmetric of this one. Inside we need to make a cut. That's why I have created a triangle inside. And this one is 1 mm. And go for equal. This one and this one are equal. Press the roller to confirm. Now just say OK. Now it is generated the triangular helix profile. Now use the option called remove material. Now it is generating the same cut in our material also. Then go for OK. Now we have created a thread, but thread ends with this way. So to remove this way of cutting, just select the surface, go for sketch, sketch view. Now project these lines by using a project options. This one, and this one. Then close it, say OK, then extrude, change the direction. Here we'll make it 2 next, material removal, say OK. So this is the way the thread will end. So now we have created the thread to this bolt. Now we can save this model. Just go for file, save as, save a copy. This is the 4th component. So 4th bolt. Now just from the same component itself we can modify. Now we are going to learn how to create this nut also. For that, just go to file, close. Go for new part solid, untick this use default template, say OK. Here choose part solid absolute, say OK. Just select this front plane, sketch view. Here our bolt is same M12 bolt with a 10 mm thickness. Just again go for palette, hexagon, just double click here and place it here, then close it. Just move the center point to center point of this one and press the roller and remove this dimension and just go for the dimension from this point to this point. The diameter will be 24 because it is M12 bolt, and go for the coincident constraint, make this point to this point coincident. Just say OK. Go for fit screen, extrude, make it symmetric, total thickness is 10 mm, say OK. Then we just want to create a hole. Just select the surface, sketch view, take a circle, just create a circle. This one is 12 mm, say OK. Then go for extrude, change the direction. Here we make it 2 next, material removal, say OK. Now we have created, then one side here we can clearly see that there is a round. For that we need to choose a plane which has 2 sides. So this plane we need to choose, sketch view, go for cut section. Now we are going to use a revolve tool to create this chamber, round. For that use the center line. Now take a line, any one option we can make. I am going to make it here. Just create a line like this, press the roller to confirm, again press the roller to confirm. This one you make it 3, say OK. Go for revolve, material removal, say OK. Now we have created a chamber. Then we just want to create a inner thread with the same pitch of 1 and height also we want. For that select this plane or directly go for helical sweep, define, select this plane, sketch it, sketch view. Now just go for cut section. Now we just want to create a thread inside. For that, just first create datum center line, press the roller to confirm, then go for reference. This line we need a reference, then close it. Then first create a line. We need to start somewhere away from the point, and here also just make it away. Press the roller to confirm. Just say OK. The pitch will be 1. And go for the section of thread making. The section, just go for sketch view. Go for the cut section again. Now we just want to make a material removal of outer side. So that we just want to create a triangle outer side. This way. Press the roller to confirm. Again press the roller to confirm. As I said, a equilateral triangle I am going to create. And make all the sides are equal. Use this equal constraint. This one and this one are equal. Now just say OK. Now thread is making. Go for material removal. If you want to change the right hand thread or left hand thread, you can change it. Just say OK. Now we have created a bolt also. Now we can save this file. Just go for file, save as, save a copy. This is the 5th component, nut. Hello everyone. In this tutorial, we are seeing how to model this flange coupling assembly. In last videos, we have seen how to model flange, shaft, taper key, bolt and nut. Now we'll assemble the component using this cut section view. For that, first go to the Creo Parametric, new, part. Here instead of go per part, choose assembly. Here untick this use default template, say OK. Our units are in mm, so choose MMNS assembly design absolute, this one, say OK. Now switch on all the planes. Now we are in the assembly model. For easy assembly, we will keep this left side and we'll keep this right side so that we can see the assembly, how we can assemble it. First we'll take the flange. Go for file, assemble. The first component is flange, so choose this flange. If you want to see the preview, just click here. You can preview the component by seeing the preview. Just press the roller to rotate your component and check the component. Just open it. The component will come into our model. And every component in the assembly model will have a 6 degree of freedom. Here you can see it has 3 translation degree of freedom. And similarly 3 rotational degree of freedom. So first component will make it default constraint. Just go for here. There are 2 types. One is connection type. Another one is current constraint. Current constraint is automatic. Now make it to default. The first component you always make it to default. Just say OK. The first component is fully constrained. Now we'll make a second component. Now we'll import the second component as shaft. Just go for the assembly. The second component is shaft. Now you can rotate the component by using the mouse, by pressing the mouse roller. Just say open. Now the second component is came into the model. Just orient your model for your assembly. I just want to assemble this shaft to here. Just orient to your model. It will be easy to assemble. Just translating this. Now it is made automatically constraint. Just delete it. Now make a constraint. First I am going to make a axis constraint. Here there is axis. Now just move your cursor to the center of the shaft. You can able to see the axis. First one you make it axis. These two are axis constraint. Then you orient axis. Both the axes are coincident. You make it coincident. Then this surface has to coincident with this surface, this keyway surface. For that, just select this surface and select this surface. Here we make it coincident. Now second constraint also I have done. The only constraint is this translation, we need to arrest it. Here you can see the shaft is located 5 mm inside the flange. So we need to place this shaft 5 mm inside. Just select the surface and select the surface. This both are in distance constraint with the distance of 5 mm. Just make it 5. Press. Here you can see fully constraint. We have given 3. Mostly we need to give 3 constraint to arrest the degree of freedom. Just say OK. Now we have assembled the shaft also. Then we'll place the key. Just go for assemble. Just open the key, which is tapper key. Just open it. Now tapper key is we have imported into the assembly model. Just rotate your tapper key and place it here. Then we can easily insert the tapper key into the model. Just rotate it here and rotate it here also, and translate, just translate. This also just translate and keep it here. This also just make it rotate. Now just press the roller to confirm and check the blue color. Which one is the flat surface? This is the flat surface and this is the highest edge surface. So we need to place the keyway in the same way. Now just go for right click here, edit. First make a constraint of this bottom flat surface coincident with this flat surface, this one. Make it coincident. Then this surface, the side surface, has to coincident with the side surface of the flange. Just make it coincident. The second also we have done. The third feature is this distance. Here you can see we have only a one constraint, which is this translation constraint. That is, we need to arrest it. Just select the surface. This has to be coincident with this surface. Here automatically it comes with the distance. Change this into coincident. Now we have placed this key also. Here you can see fully constraint. Say OK. The yellow color indicates also the fully constraint. See, the component is become yellow, means it is a fully constraint. Just say OK. Now one side we have assembled it. The second side also we need to assemble. Here we are the keyway is coming here, and here the keyway is coming this side. 90 degree we need to rotate and orient the flange. For that, just go to assemble and import the flange again. Same flange, we can import it. Just rotate this flange and the keyway is coming same direction. We need to rotate to 90 degree. Yes. Now just this hole has to orient with this hole. For that, just zoom it and take this whole axis to this whole axis. Make it coincident. First constraint we have done. Just move it to here. And the second constraint, you make it this hole. Just use your mouse roller and things. We can zoom it and zoom it out. This axis, this both are should be in coincident. Now finally we just want to make this surface should be coincident with this surface. We make it coincident. Now see, it is properly oriented to all the holes. And say OK. Just hide all the planes and axes. Now we have oriented both these flanges. Then we'll place this shaft. Here you can see this shaft is 5 mm this side to this. Now we'll place this shaft. For placing this shaft, we just hide these 3. Just hide it. Now just simply take the shaft. Just open it. Just rotate. Just rotate this here also. Just translate it to here. Now switch on simply axis. This axis has to orient with this axis. You make it coincident. Now the second constraint is this keyway cut slot has to match with this slot. This should be coincident. Then final constraint is this surface to this surface, which is distance, and to this side, which is 5 mm. Just press the roller. Now we have placed this shaft also. Then we need to place the key. Just go for assemble. Take the tapper key. Just open it. Just rotate the tapper key. And rotate to this side. And translate. And keep it here. Translate. Now just move to outside. Now we can place this. First we make a constraint to this surface, which is coincident. Now it will come properly. Now then you just this surface should be matched with this surface with the coincident. Then finally this surface match with this surface. You make it constant and press the roller to confirm. Now we have assembled all the shaft and flange. Just view this here. Then we just want to put the nut and bolt. First import the bolt. Just open the bolt. The bolt is came. Just rotate it and translate it to place it here. First constraint is this flat surface has to match with this surface. Then this axis has to match with the axis of this one. Here we make it coincident. Here automatically the allow assumption will make the cylindrical component to make a fully constrained. So now it is fully constrained. Just say OK. The same word we can do in two options. One is we can go for a repeat command by selecting this one. We can go for repeat command to place this bolt to all other 3 holes, or we can go for pattern also. Now in this tutorial we are going to learn how to use pattern. Just select this bolt. First you assemble this nut. Go for assembly. Just assemble. Choose the nut. Open. Now nut is came. Now just orient your nut. Now the nut axis has to coincide with the axis of this one. Just switch on only axis. We have an axis nut. Now just select this surface and this surface. Yes, we have axis. Select this axis and select this axis. This is to make it coincident. Now see, automatically it is become fully constrained. Now we need to make coincident of this hole. Delete. This nut axis has to coincident with this axis. Make it coincident. Now see, the nut is came and placed here. Press the roller to confirm. Now we have placed one bolt and nut. Now we can go for a pattern tool to make a copy to other holes. Just simply select this bolt and nut. It is not enabled. Only select the bolt. Now pattern is enabled now. Just go for pattern. Choose the axis pattern. Choose this axis. Here make it 360 degree and save OK. Now see, all the bolts are placed. Now we can go for same way to nut also. Select this nut. Go for pattern. Go for axis pattern. Select the axis of this one and make it 360 degree. Save OK. Now we have placed all nut and bolt completely. Now we have done the assembly. Now we can go for a section view. Just go for the section. Here there is an option called offset section. Here just switch on the plane. I need this plane. Go for sketch view. Then switch off the just hide all the planes. Then go for sketch line. Just create a sketch like this. Press the roller to confirm. Again press the roller to confirm. Just save OK. Now we have created the cut. Just save OK. Now we have created the cut like this. And this is, we can go for section 1. Then select this one. Go for edit. Here there is an option. There is an option called exclude selected item. Just this one I need to exclude it. And this key, this bolt and nut, this bolt and nut, the shaft, and we have one key here. Is this key. Just save OK. Just go for shaded with wire edges and standard orientation. Anyway, we can come. So in that we have learned how to model the flange coupling components and how to assemble the flange coupling using Creo Parametric. Finally, we have learned how to see the section view using Creo Parametric. I hope you like this video. If you like this video, please share to your friends. For more videos, please subscribe my channel. Thank you for watching my videos. Thank you.